Hey, welcome back, Algebra 1 students. This is Unit 2, Topic 2, Lesson 5. And we're going to be talking about what's called arithmetic means, which is dealing with arithmetic and geometric sequences. We're going to focus on arithmetic sequences today, though. But first we want to talk about what makes them similar. Well, there's one main similarity, and it's not the fact that they're both sequences, because I know that's what you're all thinking, because they both have the word sequence involved. But what does that really mean? Well, not all sequences are similar to arithmetic and geometric, in the fact that these two types of sequences, what they have very much in common is the fact that they both go up at a constant rate. Now, I said up because sometimes they also go down. So they either go up or down at a constant rate. If it's an arithmetic sequence, it has a common difference. And if it's a geometric sequence, it has a common ratio because it's being multiplied by the same number each time. So that's what's important. The fact that you have to do it by the same number each and every single time. So what makes them different? Well, that's pretty obvious. Arithmetic sequences are increasing by adding or subtracting, I should say, adding a negative number. They could be going down. Or geometric sequences are either going to go up by multiplying by a number greater than 1, or they're going to go down by multiplying by a number less than 1, but also greater than 0, basically meaning a fraction or a decimal, something between 0 and 1. Now, if you're multiplying by something that's negative, now that's going to be completely different because then your pattern's going to go back and forth between positives and negatives. And I think you saw that in the last day or two. All right, so that was the warm-up. So we're going to talk about arithmetic means. What does that mean? Means, yeah, I know that's a bad joke. What does means mean? Well, you figured out means before. You learned back in like 7th grade math. You take a line of numbers and you add them all together and you divide by how many numbers there are, then that is the mean. Well, that's kind of what you're going to be doing here in a moment because you're trying to find what's the middle typical normal number, and that's what you learned back in 7th grade math. Mean means typical, normal, what's in the middle. All right, so if I know the first term is 5 and I know the third term is 11, what does the second term have to be? Now, I know some of you are thinking, well, hey, Mr. Phelps, why do I got to do something complicated? Because I know the pattern is plus 3. No, it's not plus 3. Sorry. So I know the pattern in this case. Let's see, it's going to be 8 in the middle. Yeah, it is plus 3. I'm sorry. It is plus 3. And it is kind of obvious. You know, 5 plus 3 is 8, plus 3 is 11. But what if it weren't a whole number? Sometimes it's not going to be that obvious. So there's got to be an easier way of doing that. Well, you can find the mean of the two numbers. 5 plus 11 makes 16, and divide 16. Oh, I almost did square root. If you divide 16 by 2, because there's two numbers, then that's going to give you 8. And 8 is the number in the middle. So that makes sense. Now, what do you do when there's 3 numbers in the middle? Well, you can do the exact same process. If I know the first term is 18 and the fifth term is negative 10, if I add those two numbers up, that'd be 18 plus negative 10, which gives me positive 8. Divide that by 2 because there's two numbers that I'm adding together. Means the middle number is 4. Now, what I can do now is I can just simply do that process again, but I'm going to do it in my head this time. 18 plus 4 makes 22. Divide that by 2, you get 11. So now what does it look like? It looks like it's minus 7. Minus 7. Minus 7 makes negative 3 minus 7. Negative 7 is the pattern. All right, so then the last one down here, we've got 1, 2, 3, 4, 5 different spots in the middle. And since that's an odd number, we can do it the same way. Yeah, I'll talk about that later. So I'm going to take 12, add it to negative 6, and that gives me 6. Divide 6 divided by 2, because we're trying to find the means, what's in the middle. We add the 2 and divide by 2, and that tells us that 3 is in the middle. So that means this is 3. Oh, well, what are we going to do now? Because if I do 12 plus 3 is 15 and divided by 2, that gives me 7.5 in the middle, but there is no 2.5 term. This is a discrete scenario. There's only numbers. So some of you might be saying to yourself, well, hey, I can kind of just guess and check. I know I'm going to get it right. I can tell it's going down. If I do minus 2, it's not going to make it. That's going to be 10. That's going to be 8. That's going to be 6. That doesn't work. So maybe I'll try 3. That would be 9. That would be 6. And that would be 3. Now, I'll do it that way right now, but I'm going to say there's got to be a better way on the next page. That would make this 0 and this negative 3. Yeah, guessing and checking, fine. It's great when it works, but when it doesn't work, there's got to be a better way. And that's what this question's all about. So let me show you that better way. So this time we can't just add them and divide by 2, and maybe it's not obvious because 50 and 86, that's a pretty big gap. There is another way. In fact, there's a couple of ways, but I want to show you this way because this is the way I really want you to work the most on. So we've done this, we've been writing equations by a starting point and adding a pattern once, twice, 3 times. If I add a common difference 3 times, the answer should be 86. See what I did there? Started at 50, added, the common difference plus another common difference plus another common difference should be 86. So now if I use subtraction property of equality, subtract 50 from both sides, that gives me 36. Divide both sides by 3. Division property of equality tells me that D, which stands for the common difference, is 12. So does that mean this number is 12? No, that means the common difference is 12. That means this is plus 12, plus 12, plus 12. So that means this is going to be 62, this is going to be 74, and yes, 86. It works. All right, same thing here. So we've got 40 plus 1 difference, 2 differences, 3 differences, 4 differences, 5 differences. We know that all those differences have to be the same because it is a arithmetic sequence, and that's going to give me an answer of 10. Subtract 40 from both sides gives me negative 30, and that tells me that the common difference must be negative 6, division property of equality. So that makes this 34, and that would make this 28, 22, and then this would be, what is that, 16, and then minus 6 gives me 10. See, it works. All right, last but not least, negative 23 to 5. That's going to be negative 23 plus a common difference once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So plus 7 common differences equals 5. Add 23 to both sides, and you get 28. Divide both sides by 7, and that tells you the common difference must be 4. So add 4 makes negative 19, add 4 makes negative 15, add 4 makes negative 11. Then we've got, what is that, 7, negative 7, then negative 3, then positive 1, and then positive 5. Perfect. Always going to work. All right, so a couple more examples here. It's just the same process. Well, I could do the first, I could just say 12 plus 3 makes 15. Divide that by 2. What will go in the middle is 7.5. All right, see what I did there? Question number 4. This time we've got 2 spots in the middle, so we can't just add them and divide by 2. That strategy is not going to work. So I'm going to have to say to myself, well, negative 2 plus 1, 2, 3 common differences equals 26. Add 2 to both sides. That means 3D equals 28. Divide both sides by 3. D must be, what was that? That is going to be a decimal. Did I not make a mistake here? Negative 2 plus a difference once, twice, 3 times is 26. No, I didn't make any mistakes. I wish I had my calculator here, though. So 28 divided by 3 is going to give me 9 1/3. Yes, it is. 9 1/3. Well, this is going to be interesting. So if I add 9 1/3 to negative 2, that's going to be 7 1/3. And if I add 9 1/3 to 7 1/3, that's going to be 16 2/3. Well, you're going to have to listen to me because there's no way you're going to read what I just wrote. 16 2/3, add 9 1/3 will give you 26 1/3. So, yeah, looks like that works. All right, so what do I see here? Well, I see a gap of 2. So I know I can just add them. 24 plus 6 makes 30. Divided by 2 means this has to be 15. Now, that's helpful because now I can figure out the other ones because I can tell that the pattern is negative, what is that, 9? Down 9, down 9, down 9 means this is going to be negative 3. And then down 9 again means this is negative 12. All right, last question. I'm hitting up on 9 minutes. Here we go. 16 plus a common difference once, twice, 3 times. Let's hope this works out. Equals the number 2. Subtract 16 from both sides makes negative 14. Oh, it doesn't come because both sides divided by 3. That means negative 14 divided by 3 is definitely going to give me a negative, and I was not prepared with my calculator, so negative 14 divided by 3 says 4 2/3. Negative 4 2/3. All right, so here we go. Subtract 4 2/3 from 16. Well, 16 minus 4 makes 12. Minus the 2/3 makes 11 1/3. Yeah, you're going to have to hear me. And then 11 minus 4 makes 7, but you got to minus the 2/3. So now you're down to 6 2/3. This is 6 2/3. Yeah, you're going to have to listen to me and not watch just copy from the video. Minus 4 2/3 is 2. Minus 4 2/3 again is, let's see, 2 minus 4 makes negative 2. And then decrease by 2/3 again makes negative 2 2/3. All right, there it is. Great. Awesome. Please give it a like if I helped you out. And please definitely give me a follow and let your parents know and let all your friends know that they can use these videos to help do their homework. All right, thanks for watching and have a great day.